If you're like most people, you've probably felt that overwhelming buzz around artificial intelligence lately.
Oh, definitely.
From daily news headlines to those incredible sci-fi fantasies, it can feel like a lot to keep up with, right?
It's everywhere, yeah. And the terminology alone can be like a real maze. Makes it hard to truly grasp what's actually going on under the hood.
I agree completely.
Mhm.
So our mission today is, well, to cut through that noise. We want to give you a shortcut to truly understanding AI.
Sounds good.
We're going to unpack what AI actually is, how it works, behind the scenes, what it can do for us right
And the
now.
tricky parts too, right? The challenges, the ethics.
Exactly. Those crucial challenges and ethical considerations it presents. This is going to be a journey through the foundational concepts, the key technologies, the real-world impact, all tailored to help you gain that knowledge quickly, get those aha moments without, hopefully, the information overload.
And for this deep dive, we've pulled from a really rich stack of sources. We've got everything from detailed technical explanations to historical overviews. Should be pretty comprehensive and hopefully engaging for you.
Okay, let's unpack this then. When we talk about AI, what are we really talking about? It feels like such a broad, almost elusive term sometimes.
It is broad, yeah. And that's because it's less a single invention, and more a whole field of study. At its core, AI is a set of technologies that enable computers to perform a variety of advanced functions,
Okay. Advanced functions like.
like understanding language, analyzing just huge amounts of data, making sophisticated recommendations. What's really fascinating, I think, is that AI systems are built to reason, learn, and act in a way that would normally require human intelligence.
Or handle data that's just too big for us.
Exactly. Data whose scale exceeds what humans can analyze. That's the key.
So it's not just one thing then, is a whole collection of different fields working together.
Precisely. AI is inherently multidisciplinary. It spans computer science, data analytics and statistics, hardware and software engineering, linguistics, neuroscience. Even philosophy and psychology get involved.
Wow.
So yeah, there isn't one single simple definition, and that's kind of by design. Even organizations like NASA define it in various ways. Sometimes it's about systems performing tasks under varying and unpredictable circumstances without significant human oversight, or systems that can learn from experience and improve performance.
It really sounds like it's becoming the foundational technology underpinning so much of modern computing. That example you mentioned, optical character recognition, OCR, that really brings it home.
Right.
Using AI to pull text and data out of documents, turning all that unstructured stuff into valuable structured data, basically making sense of chaos.
And that leads us perfectly into how these AI systems actually learn, because the core principle, if you really boil it down, revolves around data.
Data. Always data.
Always data. AI systems learn and improve by processing vast amounts of data, spotting patterns and relationships that, honestly, humans might just miss because there's so much of it.
So it's all about feeding it enough information for it to kind of figure things out for itself.
Pretty much. And guiding that whole process are algorithms. These are the sets of rules or instructions that tell the AI how to analyze the data and make decisions. Think of them like the recipes the AI follows.
Okay, algorithms as recipes. I like that. That clarifies it. Now let's dive into what you called the nested world of AI, how machine learning, deep learning, and generative AI all fit together. It's a bit like Russian dolls, isn't it?
That's a perfect analogy, yeah. You can think of AI, machine learning, ML, deep learning, DL, and generative AI, Gen AI, as this series of nested or derivative concepts that have evolved over decades.
Okay.
So directly underneath the big AI umbrella, we have machine learning. ML is all about creating models by training an algorithm to make predictions or decisions based on data. But here's the kicker: without explicit programming for specific tasks.
Ah, okay. So ML is where the computer learns without being explicitly told every single step. What was the big leap there, conceptually, compared to earlier AI?
That's a great question. The biggest leap was moving from systems that were explicitly programmed for every single rule, every possibility.
Right, like old school expert systems.
Exactly. To systems that could actually learn from examples. Instead of a programmer writing code for every scenario, you feed the machine data, and it discovers its own rules, its own patterns.
That's a huge shift.
It is. And while there are many ML techniques out there, linear regression, clustering, all sorts, neural networks or artificial neural networks are among the most popular types of ML algorithms today.
Neural networks, like the brain.
Well, they're modeled after the human brain structure and function, yeah?
Yeah.
They consist of these interconnected layers of nodes that work together to process really complex data. It's quite fascinating.
Wow, so it's trying to mimic how our brains work. How do these networks actually learn then? Are there different ways they're, taught?
There are indeed. Broadly speaking, there are three main learning models in ML. First, you've got supervised learning. This uses labeled training data,
Labeled, meaning.
meaning the data comes with the answers already attached. So, to teach an algorithm to recognize cats, you feed it thousands of pictures that are explicitly labeled cat. The model learns to map the image features to that label. It's essentially learning from examples where you already know the right answer.
Okay, so it's like giving it digital flashcards. Makes sense. What about when you don't have all those labels? How does it learn then?
That's where unsupervised learning comes in. Here, it learns patterns directly from unlabeled data. The end result isn't known beforehand. The algorithm looks for structure, maybe categorizing data into groups based on similarities. It's really good for pattern matching and finding hidden structures in data.
Interesting. Finding patterns without knowing what you're looking for initially.
Exactly. And then there's reinforcement learning. This is best described as learn by doing.
Learn by doing.
Yeah. You have an agent, the AI, that learns a task through trial and error. It gets positive feedback for good actions and negative feedback for bad ones. Think about teaching a robotic hand to pick up a ball. It gets rewarded for successful grasps, penalized for dropping it. It improves over time based on that feedback loop.
So it figures out the best strategy itself.
Precisely. And just quickly, there's also a mix called semi-supervised learning, which uses a bit of both labeled and unlabeled data.
Okay, that covers the ML learning styles. Now, if machine learning is about neural networks, how is deep learning different? Is it just more layers? What new capabilities did that unlock?
That's a key point. Deep learning is a subset of machine learning that uses these multi-layered neural networks, which we call deep neural networks. And yes, the key difference is that these deep networks have at least three, but usually hundreds of hidden layers, whereas classic ML models might just have one or two.
Hundreds. Wow.
Yeah. But it's not just about more layers, though there's part of it. The real power comes from the fact that these multiple layers allow the AI to automatically learn and extract features from data hierarchically.
Hierarchically, meaning?
Meaning the first layer might learn simple features, like edges or corners in an image. The next layer combines those to recognize shapes. The layer after that combines shapes to recognize objects like eyes or a nose, and so on. It builds up complexity. This ability to discover the important features in raw, complex data, rather than needing humans to engineer those features beforehand, is huge.
Ah, I see. So it learns the representations itself.
Exactly. That ability to see patterns in data, like recognizing a face from raw pixels or understanding the nuances of language, that's where its power really lies. This makes it incredibly suitable for things like natural language processing, NLP, computer vision, and other complex tasks. In fact, some form of deep learning powers most of the artificial intelligence AI applications in our lives today.
So deep learning is really what's enabling things like the facial recognition on our phones or the sophisticated language understanding in our smart assistants. That's a massive shift in capability.
It absolutely is. And within these deep neural networks, we see various architectures, kind of specialized tools for different jobs. For instance, convolutional neural networks, CNNs, are super common, especially for image recognition.
How do they work?
They work by using these distinct layers that act like filters. They scan parts of an image, looking for specific features, edges in one layer, textures in another, then combining those to identify more complex things. It's almost like how you might recognize a face, first seeing the components, then putting it all together.
That's a great way to visualize it. Okay, what about language? That seems incredibly complex with grammar and context.
For sequential data, like language or time series, we use recurrent neural networks, RNNs. The key thing about RNNs is they have a kind of memory. Yet the output from one step feeds back into the next step. So when processing a sentence, they can keep in mind the words that came before to understand the context.
That seems crucial for language.
It is. But standard RNNs can struggle with long sequences they might forget earlier context. That's where an advanced type, long short-term memory LSTM networks come in.
LSTMs? Heard of those?
Right. LSTMs have these special memory cells and gates that allow them to selectively remember or forget information over much longer sequences. They can hold on to relevant context from many steps ago. Very powerful for speech recognition, translation, predictions over time.
That's incredibly clever, managing contexts like that. Okay, and then there are those generative adversarial networks,
Right.
GCMSs you mentioned. They sound competitive.
They are. GANs are quite unique. You have two neural networks essentially competing.
Yeah.
One network, the generator, tries to create realistic examples, say, images of faces. The other network, the discriminator, tries to tell the difference between the real images and the fake ones created by the generator.
So they push each other to get better.
Exactly. The generator learns to make more convincing fakes, and the discriminator gets better at spotting them. This adversarial process results in incredibly realistic outputs. They're used to create remarkably realistic images, art, even deepfakes.
Fascinating. And speaking of creating content, this brings us right up to generative AI, which has just exploded recently. What is it exactly, and what was the big breakthrough that made this possible?
Right, generative AI or Gen AI. These are essentially deep learning models that can create complex original content. We're talking text, images, music, video, all in response to a user prompt.
How do they do that? How do they create something new?
Well, they learn the underlying patterns and structures from the massive data sets they're trained on. They basically encode a simplified representation of their training data, like learning the essence of catness from millions of cat pictures. Then, they use that learned representation to generate new content that is similar but not identical to what they saw in training.
And the breakthrough.
The evolution was dramatically accelerated by a specific type of neural network architecture called transformers.
Transformers. Okay, heard that term a lot.
You probably have. Transformers are at the core of most of today's headline-making generative AI tools, including ChatGPT and GPT-4. They really changed the game.
So transformers are kind of the secret sauce behind this current Gen AI boom. What specifically about them made such a difference compared to, say, LSTMs?
You could definitely say that. The major innovation with transformers was something called the attention mechanism.
Attention mechanism.
Yeah. Unlike older models like RNNs or LSTMs that process data sequentially, one piece after another, transformers can look at an entire sequence of data, like a whole sentence or paragraph all at once. The attention mechanism allows the model to weigh the importance of different words in the input sequence when generating the output. It can figure out which words are most relevant to which other words, no matter how far apart they are.
So it understands the relationships across the whole input simultaneously.
Exactly. This dramatically improved their ability to handle long-range dependencies, especially in language. They became incredibly powerful for text generation, translation, summarization, basically understanding and producing human-like text.
That's a profound shift in how these models process information. Okay, and you mentioned Gen AI operates in distinct phases.
That's right. It's typically a three-phase process. Phase one is training. This is where you create the foundation model.
Foundation model.
Yeah.
Like the big ones we hear about, LLMs.
Exactly, like large language models or LLMs for text. This involves training a massive deep learning algorithm on huge volumes of relevant, raw, unstructured, unlabeled data. We're talking about scraping enormous chunks of the internet, books, articles.
Sounds intensive.
Oh, it's incredibly compute-intensive, time-consuming, and expensive. We're typing millions of dollars, weeks or months of processing time on thousands of specialized processors like GPUs. It's a monumental effort. That's why initially only a few big tech companies could build them. Although the rise of open source models like Meta's Llama 2 is starting to change that, helping democratize access a bit.
Wow. Millions of dollars just for the initial training. Okay, so once you have this massive raw foundation model, what's next? How do you make it useful for specific things?
That's phase two, tuning. This is where you adapt the general purpose foundation model for specific applications or tasks.
How do you tune it?
There are a few methods. One is fine-tuning, where you take the pre-trained model and train it further on a smaller, more specific data set that is labeled for your task. Another really important method is reinforcement learning with human feedback.
Or LHF, that sounds familiar.
Yeah, this is where human reviewers evaluate the model's outputs. They might rank different responses, correct factual errors, or guide the model towards a more helpful or harmless tone. It's where human judgment helps sculpt the model's behavior to be more aligned with what users want.
So humans are still very much in the loop, refining how the AI behaves. Got it. And the third phase?
The third phase is basically ongoing. Generation, evaluation, and more tuning. You deploy the model, it generates outputs, you constantly assess how well it's doing, and you refine it further. This can happen frequently, sometimes even weekly, to improve accuracy, relevance, and safety. There's also a technique called Retrieval Augmented Generation, or RAG.
RAG.
Yeah, RAG, yeah. It's a way to help these models be more factual and up-to-date. Instead of relying solely on the knowledge baked into them during training, RAG allows the model to access and pull information from external specific data sources, like a company's internal knowledge base or recent news articles, when generating a response.
Ah, so it can look things up to give better answers. Clever.
Very. It helps combat issues like making stuff up, or what they call hallucinations.
Okay, this progression is fascinating. It sounds like AI is moving through these incredible stages of complexity. You mentioned reactive machines earlier, like Deep Blue. Where are we now in that kind of developmental scale, and how do we categorize AI's capabilities as it keeps evolving?
That's a really useful framework to keep in mind. So there are these four commonly recognized stages of AI development. Stage one, as you said, is reactive machines. Limited AI reacts based on rules, no memory, can't learn. Deep Blue beating Kasparov in chess in 97. Perfect example. Powerful, but only for chess.
Right, so no actual learning in the human sense, just really sophisticated programming for one specific thing.
Precisely. Stage two is limited memory. This is where pretty much all modern AI falls. It can use memory past data, experiences to improve over time. It learns typically through neural networks being trained with new data. Deep learning, which we just talked about, is a key part of this stage.
Okay, so we're firmly in the limited memory era. What comes next?
Well, the next stage is theory of mind. This currently does not exist. This would be AI that could genuinely understand and emulate the human mind, recognizing beliefs, intentions, desires, emotions, and reacting appropriately in social situations, like truly understanding why someone feels a certain way.
That sounds complicated.
Hugely. And stage four is self-aware AI. Also mythical, does not exist. This is the sci-fi concept of AI that is conscious, aware of its own existence, and possesses human-level intellectual and emotional capabilities.
Okay, so stages 3 and 4 are still purely theoretical. That puts things in perspective. How else do we categorize AI, maybe based on what it can actually do?
That's probably a more practical way to look at it right now. We
Okay.
categorize AI by its capability, and basically everything we currently call AI falls under artificial narrow intelligence, ANI, sometimes called weak AI.
Narrow intelligence.
Yeah. It means the AI performs only narrow sets of actions based on its specific programming and training. Think Google search, predicting stock prices, your virtual assistant like Alexa or Siri, identifying objects in photos. An AI designed for image classification won't suddenly start doing natural language processing. It's a specialized tool, very good at its one job, but not a general-purpose intelligence.
So all current AI is narrow. What's the goal beyond that?
The theoretical next step is artificial general intelligence, AGI, or strong AI. This is the hypothetical ability for a machine to sense, think, and act just like a human. It could learn, reason, and apply knowledge across a wide range of tasks, performing at or even above human levels in any intellectual pursuit.
Like a machine that can do anything a human can do
This is-
mentally.
But it's currently theoretical. Achieving AGI would likely require massive breakthroughs, including major increases in computing power and probably entirely new approaches.
And beyond AGI.
Beyond AGI is artificial superintelligence, ASI. This is the even more theoretical stage where a machine's intelligence would function in all ways superior to a human. Again, purely hypothetical. Neither AGI nor ASI exist today.
That's a really clear distinction between the reality of ANI and the theoretical future of AGI and ASI. But now I'm hearing a lot about AI agents and agentic AI. Is this a new category, or does it build on what we've discussed? Where does it fit?
That's a great question. It's definitely building on what we have, particularly generative AI. You can think of it as a natural next step, and it's potentially very significant because it pushes AI beyond just creating content or providing information toward actually taking action in the world.
Taking action. Okay, explain that. What is an AI agent?
An AI agent is essentially an autonomous AI program. It's designed to perceive its environment, make decisions, and take actions to achieve specific goals set by a user, crucially, without human intervention for every step. It can design its own workflow and use available tools like accessing websites, using software, controlling devices to get the job done.
Wait, so it's not just generating text or an image, it's actually doing things autonomously based on a goal. That sounds like a huge leap.
It's potentially a very big leap. And agentic AI takes this even further. Think of it as a system of multiple AI agents that can coordinate and collaborate to achieve even more complex goals than any single agent could manage on its own.
Multiple agents working together.
Yeah.
Wow.
So while Gen AI focuses on creating content, these agents use that capability, along with others, to interact with each other and other tools to make decisions, solve problems, and complete tasks.
Okay, this is where it gets really interesting. Can you give us a concrete example? How might an AI agent operate differently from, say, ChatGPT?
Absolutely. Let's take planning a complex trip. You could ask a generative AI like ChatGPT, what's the best time to climb Mount Everest? considering my work schedule and preferred weather conditions. It might give you great analysis and recommendation.
Right, it gives you the information.
Exactly. But an AI agent could potentially do much more. You give it the goal. Plan and book my Mount Everest climbing trip for the optimal window next spring. The agent could then research the best time, check your calendar availability, search for flights using an online travel service, book the best one, reserve a suitable hotel room in Nepal near the base camp, maybe even start arranging permits or guide services, all autonomously.
Without me having to go to the airline site, the hotel site, etc.
Potentially, yes. It coordinates the different steps and tools needed to achieve the overall goal. This highlights the key characteristics of agents: autonomy, goal-driven behavior, and adaptability. They're not just responding within predefined constraints like a standard chatbot. They're actively problem-solving and executing tasks.
That's a remarkable level of capability. Okay, so bringing this all together, why does this matter to us, the listener? What are the tangible, practical benefits and transformative applications of AI that we're seeing today or might see soon?
Well, AI offers numerous benefits across pretty much every industry and application imaginable. It's already impacting your daily life and the economy in significant ways.
Like what? What are the big ones?
One of the biggest is definitely the automation of repetitive tasks. AI is really good at handling routine digital tasks. Think data entry, collection, pre-processing, and also physical tasks like warehouse stock picking or assembly line work in manufacturing.
So it frees people up.
Exactly. It frees humans for higher value, more creative work, the stuff that requires judgment, empathy, complex problem solving. Plus, robots can perform tasks that are dull, dirty, or dangerous, jobs that are unsafe or just unpleasant for people.
So less tedious work for us and less risk for people in hazardous jobs. That sounds pretty good.
It does. Another huge benefit is reduced human error, or fewer human errors. AI algorithms, when designed and implemented correctly, are consistent. They don't get tired or distracted. This can eliminate manual errors in data processing, manufacturing quality control, and many other areas.
Consistency is key there.
Absolutely. AI can guide processes, flag potential errors before they happen, or fully automate tasks where precision is critical. This is especially important in industries such as healthcare. Think about AI-guided surgical robotics, for example, where enhanced precision can make a real difference. And because machine learning models improve with more data, their accuracy often increases over time.
More accuracy, fewer mistakes, that's vital, especially in sensitive fields like medicine. What else?
You also get more and faster insight from data. This is huge. AI, particularly deep learning, can process vastly more information more quickly than a human ever could. It can discover subtle patterns, correlations, and anomalies that we might completely miss.
So better decision making.
Leads to faster, more accurate predictions and reliable, data-driven decisions.
Yes.
This dramatically accelerates research and development. We see this in areas like predictive modeling for new drug discovery in pharmaceuticals, or analyzing complex biological data like quantifying the human genome. It speeds up scientific discovery immensely.
And AI is always on, right? That 247 availability must be a game changer for businesses.
It absolutely is. AI systems offer infinite availability, or 24/7 availability and consistency. They're not limited by human needs for breaks, sleep, or vacations. Think about AI chatbots and virtual assistants handling customer service inquiries anytime, day or night. This lightens the load on human agents and can maintain consistent quality in production environments as well.
Constant availability.
And finally, a really important one, reduced physical risks. By automating dangerous work, things like handling explosives, inspecting hazardous sites, animal control in unpredictable situations, or tasks in extreme environments like the deep ocean or outer space, AI can eliminate the need to put human workers in harm's way.
Okay, those benefits are certainly compelling, touching so many different areas. What are some of the most common real-world applications we might already be encountering, maybe without even realizing it's AI?
Oh, you encounter it all the time. Think about customer experience, service, and support. Those AI-powered chatbots you interact with online. They use natural language processing and sometimes generative AI to handle inquiries, route support tickets, provide basic troubleshooting, giving you always-on support and freeing up human agents for the really complex problems.
Right, the chatbot first, then maybe a human.
Exactly. Then there's fraud detection. This is a massive area. Banks and credit card companies use machine learning and deep learning constantly to analyze transaction patterns in real time. They look for anomalies, unusual spending locations, amounts, frequencies, to flag potentially fraudulent activity much faster than humans could, protecting both the institution and you, the consumer.
And it's definitely personalizing our online experience, isn't it? Those recommendations.
Oh, absolutely. That's personalized marketing. Retailers, streaming services, banks, they use deep learning algorithms to analyze your purchase history, browsing behavior, maybe even demographic info to recommend products or content they think you'll like. Some systems can even generate personalized copy and special offers for you in real time, tailoring the experience.
Feels a bit creepy sometimes, but often useful. What about in the workplace itself?
Big impact in human resources and recruitment. AI platforms can now streamline the hiring process significantly. They can screen resumes, match candidates to job descriptions based on skills and experience, even conduct preliminary automated interviews or assessments. This reduces the administrative burden massively and can speed up response times for candidates.
That definitely cuts down on time for both companies and people looking for jobs.
It really does. AI is also changing application development and modernization. Generative AI tools that can write code are becoming more common. They can automate repetitive coding tasks, help debug, even translate code from old legacy languages to modern ones, speeding up development and letting engineers focus on more complex architectural design.
Helping the developers develop. Nice.
Yeah. And in the industrial world, predictive maintenance is huge. Factories, airlines, energy companies. They use machine learning models to analyze data pouring in from sensors on equipment and IoT devices. These models can forecast when maintenance is likely needed or predict potential equipment failures before they happen, preventing costly downtime and improving safety.
Preventing problems before they start. Very cool. These applications truly highlight AI's transformative power. But, and there's always a but with powerful tech, whenever we talk about this stuff, we also have to consider the flip side, don't we? What are some of the biggest challenges, the risks, the ethical dilemmas we're grappling with as AI gets woven deeper into our lives?
That's absolutely crucial. Rapid AI adoption brings incredible benefits, yes, but it definitely comes with significant challenges and risks that we have to manage carefully.
Okay, like what? What are the main risk categories?
Well, first, there are data risks. AI systems are completely reliant on the data they're trained on and operate with. These data sets can be vulnerable to manipulation, like data poisoning, where someone intentionally corrupts the training data to sabotage the model, or data tampering, or just inherent data bias. And of course, cyber attacks targeting the data can lead to breaches. So ensuring data integrity, security, and quality throughout the AI lifecycle is paramount. Bad data in.
Bad results out. Got it. So data security and quality are fundamental. What about the AI models themselves? Are they vulnerable?
They are. There are model risks. Threat actors can try to target the AI models directly for theft, stealing valuable proprietary models, or reverse engineering to figure out how they work, or even unauthorized manipulation. Someone could try to tamper with the model's internal architecture or parameters to make it behave incorrectly or maliciously.
Huh. Hadn't thought about stealing the model itself.
It's a concern. Then you have operational risks. Once an AI model is deployed in the real world, it's susceptible to things like model drift, where its performance degrades over time because the real-world data starts to look different from the data it was trained on. There's also the risk of inherent bias, causing problems in operation or even breakdowns in the governance structure around the AI, leading to system failures or opening up cybersecurity vulnerabilities. A model might work perfectly in the lab but fail unexpectedly when faced with messy, unpredictable real-world inputs.
Okay, so keeping the models reliable and secure once they're out there is a constant challenge. And the ethics. That feels like the biggest minefield, perhaps.
It's certainly the one getting the most attention, and rightly so. There are significant ethics and legal risks. If organizations don't prioritize safety and ethics from the outset, they risk serious consequences like privacy violations or, very importantly, producing biased outcomes.
Biased outcomes. Can you give an example?
A powerful, often cited example is using biased training data for hiring decisions. If the historical hiring data used to train an AI recruitment tool reflects past discriminatory practices, maybe favoring certain demographic groups over others, the AI will likely learn and then perpetuate or even amplify those same biases in its recommendations. It might systematically screen out qualified candidates from underrepresented groups simply because the data told it to.
That's a stark reminder that AI isn't inherently objective. It reflects the data we feed it, biases and all. So how do we even begin to ensure AI is developed and used responsibly? What are the guardrails people talk about?
That's where AI ethics and AI governance come in. AI ethics is really a multidisciplinary field. It studies how we can optimize AI's benefits while actively reducing the risks and potential harms. AI governance, then, involves putting the actual guardrails in place. The policies, practices, standards, regulations that help ensure AI tools and systems remain safe, ethical, and aligned with human values.
And who's involved in setting up these guardrails? Just the tech companies?
No, absolutely not. It has to be a collective effort. It requires involvement from a wide range of stakeholders: developers, users, policymakers, ethicists, academics, civil society groups, everyone who has a stake in how AI impacts society.
Okay, so what are some of the core values or principles that guide responsible AI development? What should these guardrails focus on?
There are several common values that keep coming up. One is explainability and interpretability. We need explainable AI.
Explainable AI.
Yeah, techniques that help human users understand how an AI algorithm arrived at its decision or result, especially for critical applications like medical diagnosis or loan applications. If you can't understand it, how can you trust it or fix it when it goes wrong?
Makes sense. Need to peek inside the black box.
Exactly. Then there's fairness and inclusion. This is about actively working to minimize algorithmic bias, to prevent AI systems from creating or reinforcing systematic disadvantages for certain groups. This often involves things like carefully auditing data and models for bias, and ensuring diverse teams are involved in the AI development process to catch blind spots.
Diversity in, diversity out, perhaps.
Something like that. Another key value is robustness and security. Building AI systems that are reliable, that can handle exceptional conditions or unexpected inputs gracefully, and that can withstand intentional attacks or unintentional interference without causing harm.
Building resilient systems.
Right. And linked to that is accountability and transparency. This means having clear lines of responsibility for the outcomes of AI systems. Who is accountable if something goes wrong? Transparency means allowing users and overseers to understand how AI services work, evaluate their functionality, and comprehend their strengths and limitations.
Knowing who's responsible and how it works.
Yes. And finally, privacy and compliance is crucial. Protecting any personal information that might be used to train or operate AI models, controlling data input and access, and building systems that are adaptable enough to comply with evolving regulations, like Europe's GDPR, for example.
It's a complex web of technical and societal challenges. Definitely a lot to think about there. Listening to all this, it's clear that AI didn't just appear overnight. What's fascinating is how long these ideas have actually been brewing. Can you give us just a quick glimpse into AI's past? Some key moments?
Absolutely. The journey is quite long. The very idea of a machine that thinks actually goes way back, even to ancient Greece with myths of automata and mechanical men, but focusing on the modern era.
Where did it really kick off?
A pivotal moment was 1950. That's when the brilliant Alan Turing published his paper, Computing Machinery and Intelligence. He famously asked the question, can machines think? And proposed the Turing test as a way to potentially answer it.
The test to see if a machine can fool a human into thinking it's human. Still famous today.
Still debated today. Then in 1956, the term artificial intelligence was actually coined by John McCarthy at a workshop at Dartmouth College, which is often seen as the birth event of AI as a field. That same year, the first AI computer program called Logic Theorist was created.
So the name in the field started right there.
Pretty much. Fast forward a bit to 1967, Frank Rosenblatt built the Mark I perceptron. This was the first computer based on a neural network that actually learned by trial and error, a very early precursor to what we use today.
The first learning machine.
In a sense, yes.
Yeah.
Then, a crucial development came around 1980. Neural networks using an algorithm called backpropagation became widely used. Backpropagation is essentially the method that allows these networks to learn from their mistakes by adjusting their internal connections to improve accuracy. It was fundamental to making neural networks practical.
Learning from errors. Okay, and then the big public demonstrations started happening, right? Proving AI could do impressive things.
Exactly. Those really brought AI into the public eye. In 1997, IBM's Deep Blue computer famously beat the world chess champion, Garry Kasparov. That was a huge milestone, mainly for rule-based symbolic AI.
I remember that. Huge news.
It was. Then, in 2011, another IBM machine, Watson, competed on the quiz show Jeopardy and beat two human champions. This showcased major advances in natural language processing and information retrieval.
Understanding tricky questions?
Right. Then deep learning really started to shine. In 2015, Baidu's Minhua supercomputer used a deep convolutional neural network to identify and categorize images with accuracy reported to be higher than humans, a big moment for computer vision.
Better than humans at seeing, wow.
And perhaps one of the most significant milestones recently was in 2016. That's when DeepMind's AlphaGo program, developed by Google, beat Lee Sedol, one of the world's top players of the ancient game Go.
Why was Go such a big deal compared to chess?
Because Go has vastly more possible moves than chess, brute force calculation like Deep Blue used for chess just wasn't feasible. AlphaGo had to use deep neural networks and reinforcement learning to develop intuition-like strategies. Beating a top human Go player was seen as a major leap in AI's ability to master complex strategic tasks previously thought to require human intuition.
A demonstration of intuition almost. Incredible. All these steps leading up to the current boom.
Exactly. All building blocks. Then 2022 really marked the arrival of large language models, LLMs, like OpenAI's ChatGPT, into the mainstream consciousness. This created an enormous change in performance of AI that the public could directly interact with, bringing powerful generative capabilities out of the lab and into everyone's hands.
And that brings us pretty much to today. What are the current trends in 2024?
Well, current trends definitely include pushing towards multimodal models. These are AI systems that can understand and generate content across different types of data simultaneously: text, images, audio, video. Think of AI that can watch a video, listen to the audio, read captions, and understand it all together. Also, there's a lot of work on smaller models, making AI more efficient, less costly to run, and capable of operating on devices like your phone, not just in massive data centers.
Fascinating. More versatile and more accessible AI. So what does this all mean? As we've explored the incredible capabilities of AI, from, deep learning, creating art, to these AI agents potentially booking your next vacation, it's really clear these technologies aren't just static tools anymore, are they? They seem increasingly autonomous.
They certainly have that potential, yes.
So this raises a pretty important question for all of us, I think.
Yeah.
How might our daily lives, and maybe even our fundamental understanding of intelligence itself, continue to evolve as these systems become more integrated, more capable, and potentially more independent in their actions?